Picture this. It's 3 a.m. You check the dashboard. Completely green. You look at the logs. Totally empty. System health checks, all passing with flying colors. But underneath all that, the business is silently hemorrhaging $10,000 every single minute. So what do? Look, most tutorials out there will happily teach you how to spin up a pipeline or deploy a cluster, but let's be real. In the trenches, your true value as a senior engineer isn't in writing YAML. It's in knowing how to survive when that exact same YAML suddenly turns against your system. In today's explainer, we're leaving those basic tutorials way behind. We are diving deep into the world of high-stakes back-end architecture, hidden kernel-level failures, and those terrifying distributed system catastrophes. So consider this a masterclass. We're going to break down the engineering intuition that really separates a junior developer from a staff-level expert. Part 1. The silent production killer. Solving impossible production incidents requires a massive psychological shift. Take the typical junior approach, right? It's highly reactive. Juniors actually joke about the scream test, turning off a server and just waiting to see who screams. But in a massive enterprise environment, that is a guaranteed career-ending move. They restart the pod, cross their fingers, and blame the code. The senior approach, on the other hand, is completely systemic. They literally ignore the immediate noise and hunt straight for the architectural flaw. Instead of endlessly scrolling through empty logs, pros rely on network telemetry. By analyzing cloud provider flow logs, they build this mathematical dependency graph of every single byte of traffic long before they ever touch a single server. Moving on to Part 2, Surviving the DNS Stampede. Let's crack open our first autopsy. We're going to trace exactly how a routine rolling restart in a service mesh, like Istio, can silently take down your entire cluster. Here's how it plays out. Step 1. Your proxies restart simultaneously during a standard deployment. Step 2. Those Envoy sidecar clusters initialize. And, well, here's exactly where the trap snaps shut. In Istio, when a service entry is configured for DNS resolution, the proxy periodically resolves host names. The catch? That interval is hard-coded to exactly 30 seconds. So, boom, step 4. Thousands of sidecars align their DNS queries on that exact same boundary. You've just generated a thundering herd that instantly crushes core DNS. We're talking rate limits, massive latency spikes, and a complete control plane collapse. Now, the gut instinct here is usually just to scale up core DNS, right? Just throw more compute budget at the problem and hope it goes away. But honestly, that's just a band-aid. It doesn't fix the architecture. The actual solution? Introducing artificial jitter. By applying a specific environment variable, pilot DNS jitter duration, you're telling those proxies to randomize their DNS query timings. So instead of getting hit by a massive deterministic spike every 30 seconds, you mathematically smooth out that load curve into a nice, manageable, continuous wave. And why does this matter so much for your backend? Well, this one single configuration change completely eliminates those synchronized bursts. It immediately takes the pressure off your external DNS infrastructure. It stabilizes your P99 latency, and it just makes your large enterprise mesh fundamentally more resilient during mass restarts. It's not a nice-to-have, guys. It is an absolutely mandatory guardrail for any high-scale cluster. Part 3, Breaking Validation Deadlocks. Let's move right into our second autopsy. We're looking at an impossible, circular Terraform dependency graph, the kind that will completely paralyze a deployment right when you need it the most, like during disaster recovery. Follow this loop with me. Your application's DNS alias record? It can't be created until it knows the load balancer's underlying name. Okay, but the load balancer cannot be created without attaching the SSL certificate. And here is the trap. The SSL certificate cannot be issued until a DNS validation record exists. Do you see it? The physical cloud requirements form a perfect, unbroken circle. I really want you to burn this specific decision tree signal into your brain. If an infrastructure build fails with a cycle error involving DNS, load balancers, and certificates, you should always suspect a DNS validation to ALB deadlock. Seriously, a junior developer will spend hours staring at completely clean, totally valid Terraform code, trying to find a syntax error that just isn't there. But a senior, they spot this architectural flaw instantly. So how exactly do we architect our way out of this mess so our pipelines actually run deterministically? We systematically decouple the validation process. First up, use a multi-stage apply. Run your target to create the identity layer and certificate first, and then apply the traffic layer. Second, enforce strict module separation. You need to physically isolate your certificates and DNS zones into a foundation repository, keeping them completely separate from your app infrastructure. That physically prevents them from existing in the same graph. And finally,
For those absolutely critical disaster recovery domains, always keep pre-provisioned certificates sitting in standby regions. Which brings us perfectly to a core engineering philosophy. A senior engineer doesn't fight the dependency graph. They flatten the graph. Oh, and a strict warning here, guys. Do not, under any circumstances, try to fix this by logging into the Cloud Console and manually creating the certificate just to force it through. That is a tainted, human-in-the-loop fix, and I guarantee you it will absolutely break your next automated run when the state file panics.
Part 4, the default deny illusion. Let's test your intuition a bit with our final autopsy. It's 2 a.m., a threat detection system starts blaring. Turns out, a compromised pod has connected directly to a highly sensitive database. So to lock down the cluster and immediately stop the bleeding, you slap on a strict default deny network policy across all 50 namespaces. Boom, the firewall is up, the hacker is completely blocked. Take a breath, but what breaks tomorrow morning?
The answer? Literally everything. You are waking up to immediate company-wide developer paralysis. Basic standard operations like DNS resolution trying to talk to core DNS will instantly drop. Metrics scraping from Prometheus? It completely fails, leaving you totally blind. The hidden operational cost of strict zero-trust networks is that basic cluster infrastructure relies super heavily on cross-namespace communication. If you don't anticipate the need to write and maintain dozens of global exception policies before you hit apply on that firewall, well, your rushed security fix is going to cause a far worse outage than the initial breach ever did.
Part 5, the senior engineering mindset.
So stepping back from all these specific DNS and network catastrophes for a second, let's talk about the overarching philosophy that truly separates exceptional engineers from everyone else. And honestly, this might challenge some of your assumptions. You probably think senior developers got to where they are by writing incredibly elegant algorithms and architecting these beautifully complex systems, right? Actually, scratch that. They got there by becoming ruthless deleters of code. Let's see how this actually translates into daily metrics. A junior developer joins a team, and naturally, they want to prove their worth immediately. They implement shiny new APIs, they add hyper-complex validation for edge cases that will literally never, ever happen, and in a year, they might add, say, 50,000 lines of code. And everyone claps. But then a senior developer joins that exact same team. In their very first month, they go in and delete 15,000 lines of code. They rip out entire microservices and just drop external dependencies. See, the junior optimizes for complexity, while the senior systematically eliminates the cognitive load of the whole system. So, how do you actually practice this? Through strategic deletion. You need to treat every single line of code as a liability, something that can break and will absolutely require maintenance. Combine redundant functions that share logic. Ruthlessly rip out unused features and those internal dashboards that literally no one has looked at in 6 months. Eliminate premature optimizations. Like building complex caching layers for data that changes maybe once a month. And if you're pulling in this massive NPM package just to use 5% of its functionality, write that 5% yourself and drop the bulky dependency. And that leaves us with this final provocative thought. The most productive thing you can do as a developer isn't writing more code. It's writing less code that does more. The next time you're about to fight a complex dependency graph, or you're tempted to build a massive workaround for a DNS thundering herd, just stop. Ask yourself, what can I delete instead? How can I simplify this architecture so it simply cannot fail? Adopt this mindset, and your systems won't just be faster, they will survive the impossible. Thanks for exploring this explainer with me today. I'll catch you in the next one.